Module 4, Cabling, Connectivity, and Power Systems in CCTV and Smart Automation. Module Overview. Cabling, connectivity, and power systems form the circulatory system of CCTV and smart automation infrastructures. Just as the human body relies on veins and arteries to transport blood and oxygen, CCTV and smart automation systems rely on cables, connectors, and power distribution mechanisms to ensure continuous data flow, reliable connectivity, and uninterrupted operation. A poorly designed cabling layout or inadequate power distribution can render even the most sophisticated surveillance and automation equipment ineffective. This module takes a deep dive into the principles, practices, and technologies of structured cabling, connectivity solutions, and power systems for both analog and IP-based CCTV, as well as IoT-enabled smart automation platforms. 1. Fundamentals of cabling in CCTV and smart automation. Cabling is the backbone of CCTV and automation systems. Each type of system may require a specific cabling design depending on data type, video, audio, control signals, or power. Types of cables. Coaxial cable, RG59, RG6, RG11. Widely used in analog CCTV systems, characterized by a single copper conductor, dielectric insulator, metallic shield, and outer jacket. Supports analog video transmission with minimal signal interference, often paired with BNC connectors. Twisted pair cable, Cat5e, Cat6, Cat6a, Cat7. Industry standard for IP CCTV and smart automation networks. Carries data and power via PoE, power over Ethernet. Supports gigabit and even 10 gigabit Ethernet speeds for high-definition CCTV streams. Fiber optic cable, preferred for large-scale installations with long-distance runs, up to kilometers. Provides immunity against electromagnetic interference, EMI. Supports ultra-high bandwidth for 4K/8K video, AI-driven analytics, and integrated automation systems. Specialized cables, alarm and control cables, multi-core. Speaker cables for audio integration. HDMI extenders for video walls. RS485 twisted pair for PTZ camera controls. 2. Connectivity and interfaces. Connectivity ensures devices talk to each other seamlessly. Connectors for CCTV BNC connectors, used in coaxial cabling for analog cameras. RJ45 connectors, Ethernet-based CCTV and IoT devices. SC/LC connectors, Aero fiber optic, CCTV and backbone automation systems. DC power jacks, Aero power supply for individual cameras. Patch panels and keystone jacks. Used in structured cabling to organize connections. Prevent clutter and improve troubleshooting efficiency. Switches and routers. Unmanaged switches. Simple plug-and-play for small networks. Managed switches. VLANs, QoS, security, and remote monitoring. PoE switches. Deliver both data plus power to IP cameras and IoT devices. Wireless connectivity, Wi-Fi-based, IoT devices, smart locks, cameras, sensors. Mesh networking for home automation. Limitations. Signal interference, security vulnerabilities. 3. Power systems in CCTV and automation. Power is the lifeblood of CCTV and automation. Without stable power distribution, cameras fail, smart sensors go offline, and automation routines collapse. Types of power supply. Dedicated power adapters, DC 12 volts, or AC 24 volts adapters for standalone cameras. Easy to install but inefficient in large-scale systems. Centralized power supply units, PSUs. Supply power to multiple cameras/devices from a single source. Easier maintenance and protection with fuses/relays. Power over Ethernet, PoE. IEEE 802.3 AF, 15.4 watts. 802.3 AT, 30 watts. 802.3 BT, up to 90 watts. Eliminates need for separate power cabling, preferred for IP-based CCTV and smart automation. Uninterruptible power supply, UPS, and backup systems. Provide backup power during outages, essential for critical CCTV surveillance, banks, hospitals, airports. UPS systems ensure that DVRS/NVRS continue recording even when mains power fails. Renewable/alternative power sources. 4. Cable management and installation practices. Conduit and trunking protects cables from physical damage. Labeling and documentation ensures easy identification during troubleshooting. Grounding and shielding prevents electrical interference and surges. Segregation of cables. Keep power cables separate from data cables to minimize interference. Testing and certification. Use testers for Cat6/fiber to validate performance. 5. Common issues in cabling and power signal loss due to poor quality cable. Voltage drop across long distances. Loose connectors causing intermittent video feeds. PoE incompatibility between devices. EMI interference from nearby power lines or machinery. 6. Practical applications. Small home installations, Wi-Fi IP cameras with PoE injectors. Corporate offices, structured CAT. 6 cabling, PoE switches, centralized UPS. Smart cities, fiber optic backbone, solar-powered smart CCTV poles, IoT sensors. Industrial automation, shielded cabling, hardened power supplies, redundant network switches.